to evaluate the mixed cash flows. Okay, so as we have example that Julie Miller will receive a set of cash flows below. What is the present value at discounted rate of 10%? So here we have the rate of interest is 10% and we have to find out the PV. But the problem is that the cash flows are not equal. As we look, for 2 years we have $600 and for these 2 years we have $400, and again in the 5th year we have only $100. So it's not a equal cash flow, it's a mix of cash flows. And in previous we have studied that the cash flows are of a series of payment, but in this scenario we have a different thing. So how to calculate it? It's not a very difficult task. We have formula and we will apply formula for each and every cash flow, so it will bring a result for us. So how to solve it? So this is the method to solve it. Solve a piece at a time by discounting each piece back. We have to discount each and every cash flow, okay, by using present value formula. Okay, this is for a group. Okay, we will discuss it in the next slide. So we will discuss it earlier. Okay. Now, how to solve it? It's very simple. As you know, that we have a mix of cash flows: 600, 600, 400, 400, and 100. And we have interest of 10%. Or we can also write it as 10% or 0.10, and the number of years is equal to 5, and these are values of R. Okay, so how to calculate the first one? It's very simple. 600 divided by, now remember the present value formulation, it's 1.10 over 1. For the first cash flow, you have to write here 1. Okay. Now, how to calculate the second one? 600 divided by 1.10. What will be there? It will be 2. And for the third year, now the cash flow will be changed. It will be 400 because the value at the end of third period we will receive or we will pay is 400. So what will be there? Power, what will be there? It will be 3. Okay, as it's of the cash flow of third year. Now for the fourth year, how we will calculate it? 400 divided by 1.10 or 4, and at the end we have 100. So 100 divided by 1.10 power 5, because it's of the last year cash flow, which value is 5. So when you calculate cash flow of each, the present value of each cash flow, you have to sum it, and it is the value of present value of mixed cash flow. Okay, so this is the method through which you can calculate the present value of mixed cash flow. Now we have to discuss about groups. That when you have 2-3 groups, so how to calculate the present value of a group. Let's suppose you are investing or you are receiving different payments from different suppliers, from different customers. So how to calculate the present value of a group? So simply we have to remove it. We are here discussing about this, that how to calculate groups. Okay. By first breaking problem into groups, you have to break problem into groups. Let's suppose you have different customer A, customer B, customer C. You have to receive you have to receive 3 payments from this customer. Okay, you have to receive 2 payments from this customer, like this, and from this customer, the final customer, you have to receive the following payments. Okay, so first of all, breaking problem into groups of annuity streams. These have your annuity streams. Okay. Okay, then discount each group back to t is equal to 0. Each group back to 0. Okay, each group back to 0, like this. So how we can perform it? Let's see it. So here we have some groups. Okay, and their different values. Like you saw, it's the first group. Okay, and we are receiving 400. It's a series of equal payments, so it's an annuity. And as we discussed, that if we receive the amount at the end of the period, so it will be an annuity ordinary. Okay, an ordinary annuity it is. So we have to use the ordinary equity formula. Then we have to plus this amount with the other stream. Okay, so we have 200 and 200. It's again an ordinary annuity, and at the end we have a single payment after 5 years. Okay, so simply we can use the formulas of order set is 10%. So 1 0 and 1, and then 400 divided by 1.10 over 2, 400 divided by 1.10 over 3, 400 divided by 1.10 power 4. So from each and every cash flow you will get a value. Okay, you will get a value. After getting such values, we have to combine all of them and you will get this amount. Okay, so it's your home task. You have to calculate each and every value and then check this that this value is okay or not. Then we have second cash flow, second stream of cash flows. So 200 divided by 1.10 over 1, because it is 1, and then 200 divided by 1.10 power 2. Okay, so after applying this formula, you will again get some values, and after combining these values you will get this value. Okay, and at the end you have a single cash flow, but it is after 5 years. So how to calculate it? Simply 1.10 power 5. So you will get this value, which is shown to you 62.10. Okay, and after adding all such values 1, 2 and 3, you will get this value of present m. Okay, so you will get this present value of these three groups. So this is the way you can calculate the cash flows of different groups. Interest rate is annually, but sometimes we have interest rate in the form of semi-annually, quarterly, okay, and monthly, okay, and sometimes daily. So how to tackle with this? So we have the frequency of compounding, and the general formula is future value of n years is equal to present value 1 plus I you know it, interest m. What is m? We are going to discuss it, and m multiplied by n. Now m is equal to number of years. Okay, it's number of years. Now the second is compounding periods per year. M is equal to compounding period per year. Compounding period means if it is annually, so the compounding period will be equal to 1. Okay, if it is semi-annually, so the compounding period will be 2. If it is quarterly, so compounding period will be 4, up to so on. Okay, and FV, future value at the end of the year, as you know, future value, and cash flow today. Now we have different formulation. Okay, Julie Miller has 1,000 to invest for 2 years at the annual interest rate of 12%. So first of all we have to get the data. P naught, or you can say it as PV, is equal to $1,000. Okay, then we have rate of interest which is 12%. Okay, or 0.12. Then we have number of years which is 2, as invested for 2 years. Okay, then if we calculate it annually, so which formula we have discussed earlier, you can use that formula, as well as you can use this formula. If you divide it by 1, so you will get 0.1, and if you multiply it by 2, so you will get 2. So for annual series of payment, you can use that formula. Now there is a change if you are using for semi-annually. So you have to, as we know that how much compounding factors involved in this. So we have to time we have to do payment. So you have to divide interest by 2, as well as you have to multiply the power by 2. Okay, so you will get the answer. And the same procedure for quarterly. For quarter we have 4, and first we have to divide the interest rate by 4, and then we have to multiply it by 4. And if we are finding the monthly future value, so we have to divide it by 12 and then multiply it by 12. Okay, power is multiplied by 12. And if we have to find out daily, so we have to divide it by 365, because we have 365 days in a year. So you can use 365 by dividing for the division of interest rate, and also multiply with the power. Sometimes in finance we consider 360 days. What is the logic behind 360 days? Sometimes for forecasting we use the 360 days because we consider each and every month of 30 days. If you have 30 days month, so multiply it by 2, so you 12, so you will get 360. Okay, so you can use 365 as well as 360. Okay, what is effective